In this video, we are going to learn about the values of sines of different angles in all the four quadrants. Before moving forward, I hope that you have watched my previous video about the values of sines, cosines and tangents of 0 degree, 30 degrees, 45 degrees, 60 degrees and 90 degrees. If you haven't watched it yet, then I suggest you to watch that video first. You can find the link of that video on the top of this slide. Let's start. Here is a table. It contains 2 rows and 6 columns. The angles 0 degree, 30 degrees, 45 degrees, 60 degrees and 90 degrees are enlisted in the first row. The values of sine of these angles are enlisted in the second row. That is, sine of 0 degree is 0. Sine of 30 degrees is 1 by 2. Sine of 45 degrees is half of square root of 2. Sine of 60 degrees is half of square root of 3. And sine of 90 degrees is 1. The terminal rays of all these angles lie in the first quadrant. And note that the values of sine of these angles are increased from a minimum value 0 to a maximum value 1. And here is the figure of the unit circle. What is a unit circle? A unit circle is a circle whose center is at the origin and whose radius is equal to 1 unit. Have a look at this blue line. This blue line is equal to radius of unit circle. It means its length is equal to 1 unit. It makes an angle 0 degree with the positive x-axis. It is the terminal side of the angle 0 degree. The initial side of the angle 0 degree is headed towards positive x-axis. And the terminal side of the angle 0 degree is also headed towards positive x-axis. We shall come back to this slide later. Let's move to next slide now. In this figure, the line OP is equal to radius of unit circle. It means its length is equal to 1 unit. It is the terminal side of the angle 30 degrees. And the line PQ is a perpendicular line that we have drawn from point P on the x-axis. If we measure the length of PQ as compared to the length of OP, it would be equal to half of the length of OP. As the length of OP is 1 unit, it means the length of PQ is equal to 1 by 2. The length of this perpendicular line PQ gives the value of sine of 30 degrees. That is, sine of 30 degrees is equal to 1 by 2. Let's move back to previous slide now. As I said earlier, this blue line is the terminal side of the angle 0 degree. If we try to draw a perpendicular line from the head of this terminal side on the x-axis, the length of this perpendicular line would be equal to 0. So, sine of 0 degree is 0. But in this case, when the angle is 30 degree, we have a perpendicular line PQ whose length is 1 by 2. So that is why sine of 30 degrees is equal to 1 by 2. In this figure, the line OP is the terminal side of the angle 45 degrees. And the line PQ is a perpendicular line whose length is equal to half of square root of 2. This line gives the value of sine of 45 degrees. As the length of PQ is equal to half of square root of 2, it means sine of 45 degrees is equal to half of square root of 2. In this figure, the line OP is the terminal side of the angle 60 degrees. And the line PQ gives the value of sine of 60 degrees. The length of PQ is equal to half of square root of 3. So sine of 60 degrees is equal to half of square root of 3. In this figure, the vertical brown line is the terminal side of the angle 90 degrees. The initial side of the angle 90 degrees is headed toward positive x-axis. The terminal side of the angle 90 degree is headed toward positive y-axis. We know that the angle between positive x-axis and positive y-axis is 90 degree. Now, if we try to draw a perpendicular from the head of this brown line, that is the point B, on the x-axis, the length of this perpendicular line would be exactly equal to the radius of the circle and equal to this brown line itself. And length of that perpendicular line gives the value of sine of 90 degrees. So sine of 90 degrees is 1. Observe all these things in this figure. When angle is 0 degree, we don't have any vertical line. When angle is 30 degree, we have a vertical green line whose length is 1 by 2. It gives the value of sine of 30 degrees. When angle is 45 degree, we have a vertical red line whose length is equal to half of square root of 2. When angle is 60 degrees, we have a vertical yellow line whose length is half of square root of 3. And when angle is 90 degree, we have a vertical brown line whose length is 1. When angle is 0 degree, the vertical blue line is equal to 0 units, so sine of 0 degree is 0. The length of the vertical green line is 1 by 2, which gives the value of sine of 30 degrees. So sine of 30 degrees is equal to 1 by 2. Similarly, sine of 45 degrees is equal to half of square root of 2. Sine of 60 degrees is equal to half of square root of 3. And sine of 90 degrees is equal to 1. Let's move to next quadrant. Observe the transition carefully. Let's move back. When we move from first quadrant to second quadrant, all these triangles are flipped horizontally across y-axis. In this figure, the vertical brown line gives the value of sine of 90 degree. So sine of 90 degree is equal to 1. The vertical yellow line gives the value of sine of 120 degree. So sine of 120 degree is equal to half of square root of 3. The vertical red line gives the value of sine of 135 degrees. So sine of 135 degrees is equal to half of square root of 2. Similarly, sine of 150 degrees is equal to 1 by 2. And sine of 180 degrees is 0. As in this case, we don't have vertical line. Its length is 0. So sine of 180 degrees is 0. Let's move to next quadrant. Observe the transition again. When we move from second quadrant to third quadrant, all the triangles are flipped vertically across x-axis. In this figure, the vertical blue line gives the value of sine of 180 degrees. We don't have any vertical blue line. It means its length is 0. So sine of 180 degrees is 0. The vertical green line, whose length is equal to 1 by 2 and which is directed toward negative y-axis, gives the value of sine of 210 degrees. I repeat, the vertical green line has length equal to 1 by 2 units and it is directed toward negative y-axis. It gives the value of sine of 210 degrees. As this line is directed toward negative y-axis, so sine of 210 degree has negative value. Sine of 210 degree is equal to minus 1 by 2. The vertical red line is equal to half of square root of 2 and it is directed toward negative y-axis as well. So sine of 225 degrees is equal to minus square root of 2 by 2. Similarly, sine of 240 degrees is equal to minus half of square root of 3, and sine of 270 degrees is equal to minus 1. Let's move to next quadrant now. Observe the transition again. When we move from third quadrant into fourth quadrant, all the triangles are flipped horizontally across y-axis. In this figure, the vertical brown line, which is equal to 1 unit in length and which is directed toward negative y-axis, gives the value of sine of 270 degrees. So sine of 270 degrees is equal to minus 1. Similarly, vertical yellow line, which is equal to half of square root of 3 and which is headed toward negative y-axis as well, gives the value of sine of 300 degrees. So sine of 300 degrees is equal to minus square root of 3 by 2. Similarly, sine of 315 degrees is equal to minus square root of 2 by 2. Sine of 330 degrees is equal to minus 1 by 2, and sine of 360 degrees is equal to 0. As in this case, we don't have any vertical blue line. So that is why sine of 360 degrees is 0. Now have a look at this beautiful colorful butterfly figure. Observe this figure carefully. Have a look at vertical green line in the first quadrant and vertical green line in the second quadrant. This is the horizontal comparison. The length of the vertical green line in the first quadrant is exactly equal to the length of the vertical green line in the second quadrant. It means the value of sine of 30 degrees is exactly equal to the value of sine of 150 degrees. Similarly, when angle is 0 degree, the value of sine is 0, and when angle is 180 degrees, the value of sine is also 0. So sine of 0 degree is equal to sine of 180 degrees. Similarly, sine of 30 degrees is equal to sine of 150 degrees. Sine of 45 degrees is equal to sine of 135 degrees. Sine of 60 degrees is equal to sine of 120 degrees. Now observe the length of vertical green line in the third quadrant is exactly equal to the length of vertical green line in the fourth quadrant. It means the value of sine of 210 degrees is equal to sine of 330 degrees. That is, sine of 210 degrees is equal to sine of 330 degrees. Similarly, sine of 225 degrees is equal to sine of 315 degrees. Sine of 240 degrees is equal to sine of 300 degrees. Vertical comparison. Note that the length of vertical green line in the first quadrant is exactly equal to the length of vertical green line in the fourth quadrant, but both the lines are opposite in direction. The vertical green line in the first quadrant is headed toward positive y-axis, whereas the vertical green line in the fourth quadrant is headed toward negative y-axis. It means sine of 30 degrees is equal to minus sine of 330 degrees. Similarly, sine of 45 degrees is equal to minus sine of 315 degrees. Sine of 60 degrees is equal to minus sine of 300 degrees. Sine of 90 degrees is equal to minus sine of 270 degrees. Sine of 150 degree is equal to minus sine of 210 degrees. Sine of 135 degrees is equal to minus sine of 225 degrees, and sine of 120 degrees is equal to minus sine of 240 degrees. Diagonal comparison. Note that the length of the vertical green line in the first quadrant is equal to the length of the vertical green line in the third quadrant, but both the lines have opposite direction. The vertical green line in the first quadrant is headed toward positive y-axis, whereas the vertical green line in the third quadrant is headed toward negative y-axis. It means sine of 30 degrees is equal to minus sine of 210 degrees. Similarly, sine of 45 degrees is equal to minus sine of 225 degrees. Sine of 60 degrees is equal to minus sine of 240 degrees. Sine of 90 degrees is equal to minus sine of 270 degrees. Sine of 150 degrees is equal to minus sine of 330 degrees. Sine of 135 degrees is equal to minus sine of 315 degrees, and sine of 120 degrees is equal to minus sine of 300 degrees. Sine convention. The values of sines of all the angles with terminal rays in first and second quadrant are positive, as their representative lines are headed towards positive y-axis. I repeat, the values of sines of all the angles with terminal rays in first and second quadrants are positive, as their representative lines are headed toward positive y-axis. Similarly, the values of sines of all the angles with terminal rays in third and fourth quadrants are negative, as their representative lines are headed toward negative y-axis. I repeat, the values of sines of all the angles with terminal rays in third and fourth quadrant are negative, as their representative lines are headed toward negative y-axis. And this is the end of this video. Thank you for being with me. Goodbye.